Hi everyone. This presentation is about, again, a very complex nature of a perimenopausal presentation, but this time it is weight gain in the perimenopausal patient and why it's resistant to most dietary interventions. My disclosure again is that my company Bio-Alai offers nutritional solutions and education to help practitioners provide a more holistic model of care. But what I'll talk about today are the processes that influence weight gain with a focus on the gut-brain fat axis and how resistant fat develops. And I'll look at the role that estrogen deficiency plays and how nutritional interventions can be used to help shift stubborn fat. So perimenopause, as we all know, it's a time of hormonal disruptions that are usually accompanied by weight gain despite all efforts. So hormonal imbalances were believed to be the main driver, but it's now recognized that it's very much multifactorial. So it's driven mainly by epigenetic factors like diet, lifestyle, and environmental exposures because of the effects they have on our gut microbiome, on our epigenome and gene expression, on our immune system, hormones, and even brain function. So all of these factors need to be addressed for successful weight loss, but it often needs to begin with reshaping our conditioned beliefs around food and our need for a quick fix, because these are sometimes the greatest obstacles. So I'm just going to touch on the conditioned beliefs aspect because we're bombarded by very clever marketing our entire lives, and it pervasively influences our beliefs and our choices. So just to give you an example of some really great marketing, in 2004, Dove started a campaign for real beauty. Dove is a subsidiary of Unilever, and in that same year, another subsidiary, Streets Ice Cream, launched the Magnum Indulgence campaign. So these two campaigns were very well timed, and between the two subsidiary companies, the message was to accept your body shape and not conform to the norms of beauty, and of course, don't deprive yourself of an indulgence. So since then, there's been an increase in obese and overweight individuals by 13%. And despite all of the many approved weight loss drugs and a growing diet industry, the statistics just continue to rise. And it's because we're hardwired to seek pleasure from food from a very early age. And I'm not going to talk anymore about that aspect of weight management, but what I'm going to do is look at how we can improve the internal signals that our brain receives so that we can help improve cognitive function and resilience to these messages like these. So under normal conditions, our weight is regulated by internal signals from the gut, the pancreas, and the adipose tissue that are transmitted to the hypothalamus, which integrates information from various brain regions to produce an output that regulates appetite and metabolism and regulates a number of other hormonal and neuroendocrine functions. And inputs also come from the sensory system, the prefrontal cortex, which is responsible for decision making, and the mesolimbic system, which includes the emotional control center and reward pathways in the brain. So the way it works is that when we eat a healthy meal, the dietary fiber and polyphenols are digested by the gut microbiome, which produces metabolites that directly signal satiety to the brain and indirectly activate the release of gut peptides like glucagon-like peptide that in turn signals satiety to the brain. And certain nutrients from the food become substrates for neurotransmitters, and therefore they can indirectly improve satiety. So there is a very sophisticated communication system between the gut and the brain via the bloodstream and also via the vagus nerve. The glucose that comes from the meal, that's derived from the carbohydrates in the meal, activates insulin release from the pancreas, which helps the muscle, liver, and neurons utilize glucose. And so it helps clear it from the bloodstream. And glucose is the main energy source in neurons, and it supports satiety in the short term. Adipose tissue will store any excess fat or glucose from the meal and and as it does so, it releases a hormone called leptin, which signals satiety to the brain. So these are the satiety signals that tell the brain to stop eating and to increase our metabolism. When we're hungry, we only have one hunger signal, which is a hormone called ghrelin, and it tells the hypothalamus that the stomach is empty and it's time to eat. So food intake and metabolism are regulated by a number of satiety signals and only one hormone signal. So you would think that satiety would be our dominant state, but unfortunately our Western diet and lifestyle disrupt the function of all of these organs, and I'll explain how this happens in a couple of slides. Now, when it comes to actual fat loss, there are two processes involved. So firstly, we have lipolysis, which occurs in adipocytes, and it relies on adrenaline and low insulin because insulin is generally a fat storing hormone. The second process is fat oxidation by mitochondria, and this occurs largely in the liver, the muscle cells, brown fat in the brain, and mitochondria rely on macro and micronutrients to produce energy for the cell, and glucose needs to be low so that mitochondria use fat as a fuel source. And hormones like cortisol, thyroid, and sex hormones also play a role. Estrogen actually supports mitochondrial function, and studies have found that premenopausal women have a much greater ability to oxidize fat during exercise. The gut microbiome, though, is very central to all of these processes. So it's involved in all of the processes that are important for weight management, and it does it through its metabolites. And everyone has a unique baseline microbiome. So some people can have species that can extract more calories from food. Others have species that impair lipolysis or impair glycemic control. And there are species also that can interfere with satiety signals. So this is why one of the reasons why two people who are following the same diet can get very different results. The good news is, though, that the microbiome is modifiable through dietary intervention. So you can see on the right here are the beneficial effects of a healthy diet on microbial composition, immune function, and also on metabolism. But the reason why resistant fat develops is actually what you see here on the left, which is the cascade of damage that's produced by the Western diet, which begins with gut dysbiosis and the release of endotoxin from pathogenic species. Endotoxin goes on to disrupt the gut barrier and activate the immune systems that cause an inflammatory response in the gastrointestinal tract, and then this is transmitted to distal organs. And I've said this in one of my previous presentations, but the gut is the greatest source of inflammation in the body because that's where most of our immune cells reside, and the immune system is basically primed there. And so the inflammation that's transmitted from the gastrointestinal tract goes on to change the function of the key organs involved in weight homeostasis. So it leads to insulin resistance in the periphery and insulin and leptin resistance in the brain. So the brain stops sensing satiety signals, which means this is one of the reasons why in some people there is sometimes no off switch when it comes to food. And as we age, there are also molecular and cellular mechanisms that are known as the hallmarks of aging that further slow down fat loss by worsening inflammation within all organs and disrupting satiety signals and glucose sensing, and also causing mitochondrial dysfunction and a buildup of oxidative stress, which in turn damages cell components. And this combined with a loss of autophagy, which would normally recycle cellular debris, it leads to a buildup of senescent cells within organs. So these are cells that no longer function, but they secrete specific inflammatory cytokines that turn adjacent cells into senescent cells. And this is what's known as inflammaging. Now, senescent cells build up in all organs at different rates. And if there's a buildup of senescent cells within adipose tissue, it contributes to resistant fat because these cells can't release stored fat. And the inflammation that they produce can cause fibrosis, and it can damage vessels and lymphatics, which makes the tissue even more resistant to fat loss. In obesity, there are senescent cells that are found not just in adipose tissue, but also in the liver, in the pancreas, in muscle, and in the brain as well. And during menopause, there's another layer to it. There's also adipocyte hypertrophy, which worsens blood flow and therefore is more likely to lead to fibrosis and therefore makes it even harder to lose weight, so making the fat even more resistant to weight loss measures. So menopausal fat shares many of the features of lipedema fat, which is an extreme form of resistant fat that is very sensitive to food triggers that alter the gut microbiome and then in turn activate an inflammatory response in the fatty tissue, or indirectly certain foods particularly in susceptible individuals can activate mast cells that are present within the fatty tissue. And so one thing that I've seen in my practice is that many peri and postmenopausal patients tend to report that their legs can sometimes swell within hours of eating certain foods. And that so this is potentially one of the reasons why this might be the case. So mast cells appear to play a role in that perimenopausal weight gain as well. And this is why the right dietary modifications can make a big difference. And I'll show you a bit more on that later on. But there's still a lot more to the picture because there are estrogen receptors in all of the organs and systems involved in weight management, and it plays a supportive role there. So as estrogen declines, there are changes in the gut microbiome and a loss of gut wall integrity. There's also activation of the inflammasome in immune cells and worsening systemic inflammation and insulin resistance, and this goes on to disrupt or impair fat loss and disrupt metabolism as well. And then in the brain, estrogen deficiency worsens neuroinflammation and it impairs mitochondrial function in neurons. It reduces neuroplasticity and it produces a heightened stress response. So these significantly affect all aspects of brain function, which is why women can experience a range of neurological and neuropsychiatric symptoms as well. And there are also changes in the structural and functional connectivity of the brain, similar to those seen in obesity or depression. And so this makes it even harder to override cravings and resist triggers. So the changes that are seen is that there are lower volumes in the prefrontal cortex. And so there's a decline in cognitive function and impaired decision making. And there's heightened activity in the mesolimbic regions, which is why people tend to turn to emotional eating, basically. So another issue that occurs is that the ability to rewire these maladaptive changes is reduced because neuroinflammation inhibits a growth factor called brain-derived neurotrophic factor, which is essential for neuroplasticity. So those with these changes are stuck in a vicious cycle. And hormone replacement therapy, if it's started early, can potentially prevent some of these neurological effects, but it has very limited benefits once they've been established. And another factor is it doesn't really assist weight loss because the drivers of inflammation continue. So currently one of the most popular medications for weight loss are glucagon-like 1 receptor agonists, like Ozempic, for example. And I'm sure many of your patients may be asking you about them. So in the literature, their benefits really do seem to outweigh the risk for those with diabetes or obesity or chronic conditions, or those who are at risk of serious chronic conditions. They can really be a game changer. But for those who just have some stubborn weight to shift, they're not necessarily the best option. You can see here in this image that they really only form a very small part of the picture. So the mechanisms through which they produce weight loss, one of them is to reduce gut transit time and to increase fullness. They also increase the release of insulin that goes on to regulate blood glucose, which can help reduce cravings and inflammation. But the mechanism, the action through which they produce significant weight loss is their appetite suppressant effect on the brain, which reduces food intake. And the benefits are that the patient eats less, and there are some real risks with suppressing your appetite. And this is, I'll explain why. So When we support our endogenous production of glucagon-like peptide by improving diet and our gut microbiome, we're also supporting all aspects of weight homeostasis, so appetite just naturally normalizes. When we use exogenous peptide agonists, they have an appetite suppressing effect that goes above that produced with physiological levels. So this is the main reason for rapid weight loss. But the weight is almost always regained on stopping, and there are a number of reasons for this. Firstly, up to half of the weight that's lost comes from muscle mass, and this goes on to damage metabolism. Secondly, most of the people who are on these peptide agonists, they eat less, but they don't change the quality of the food. So the effects of dysbiosis and neuroinflammation continue. But what ultimately makes or breaks the end result is how the peptide agonists affect brain function. And studies are finding that tolerance is developing to some of the benefits of these peptide agonists, suggesting that there is a downregulation of peptide receptors. And if this occurs in the brain, it changes the functional connectome of the brain. And this has certainly been found with earlier appetite suppressants, and it's a finding that has been in humans. We don't know whether this occurs with these particular peptide agonists. It may be many years before it's fully clarified for us. But neuroplasticity is certainly well researched, and we know that neuroplasticity increases in areas of higher need because energy and brain-derived neurotrophic factor are directed where they're needed. So when we practice a certain task or behavior, there is increased neuroplasticity in the brain regions responsible for that particular action. And that's what was found in this human study. With this study used a multimodal health intervention. Now, the question is, what happens if we instead use an appetite suppressant that reduces the need to actively enlist the prefrontal cortex to override cravings and resist temptations? And what we do know from previous studies is that if a brain region isn't being used, there'll be atrophy and there'll be a loss of connectivity. So in this particular case, it's possible, or in the case of peptide agonists, it's possible that an inability to resist triggers or food triggers or cravings may be the key reason why weight is regained when these peptide agonists are stopped. So a safer option, obviously, is to address the modifiable factors that cause dysbiosis and inflammation, because these are the drivers of resistant fat. Because if we're not addressing these, then everything else is really just a Band-Aid. But to give you an example of what's possible when the right modifications are made, in this study, a low-carb, unprocessed, calorie-restricted diet was able to produce fat loss in those with lipedema. And lipedema is the most extreme form of resistant fat. And the reason why it worked was because it reduces inflammation and produces a metabolic shift that restores mitochondrial function and insulin sensitivity. It activates autophagy to remove senescent cells, and it reduces neuroinflammation, which of course goes on to improve cognitive function and decision-making and emotional regulation. So it generally makes it much easier to develop healthy habits. So I use nutritional interventions to normalize cellular and systemic processes that are involved in chronic disease. And in doing so, appetite normalizes and brain function improves, and it makes it easier to maintain any benefits achieved long term. So I always use personalized nutrition, because everyone has a different inflammatory response to different food components or compounds, and a different metabolic response to different dietary techniques. And I add supplements to address each of the key processes. So I'll just show you a couple of my patients who weren't able to shift the perimenopausal fat with previous diets, but it came off quite rapidly when they started the right plan for them. So this is a 48-year-old female with a history of bowel issues, weight gain, and resistant fat. So she had tried many diets without success, but she lost 10 kilos in 8 weeks with a personalized nutrition plan and supplements. One thing, though, that I did want to note is that in this patient, she rapidly lost weight from her upper arms, and you can see in the photos that the fat had an uneven appearance, which suggests that the tissue had undergone many of the changes that would make it quite resistant, and yet it still came off quite rapidly. This is a 58-year-old patient who gained weight after treatment for breast cancer, and she just hadn't been able to lose the weight despite all efforts until she completed one of my plans, and she's now maintained it for over 2 years. And this is another patient who gained weight again after treatment for breast cancer. And one thing that she noted was that on completion of the plan, she felt comfortable wearing sleeveless tops for the first time in many years. So I know that these images aren't as impressive as we're seeing with Ozempic, but these images are images of healthy, these after images are images of healthy bodies. And this makes it easier to either continue the weight loss or to maintain it long term. And this is the ultimate goal for a perimenopausal and menopausal patient. Their bodies have undergone such significant changes and they just don't feel like themselves anymore. Many of them have tried every single diet out there, including Ozempic, only to regain the weight, and then they feel like failures. So by restoring physiological processes that are essential for health and weight management, they're able to feel like themselves again and live in a healthier body from here on. So for the perimenopausal patients who are finding it hard to shift that stubborn weight, there are some simple dietary and lifestyle changes that can really improve the internal environment and help mobilize that resistant fat and also support brain function, which makes long-term maintenance easier. If you'd like to find out more about how you can implement it into your practice or implement my plans and nutraceutical products into your practice so you can provide a more holistic approach, please visit our website or email me. Thank you.